Hi! Welcome to our lesson about climate modelling and simulation. Let's check. What will we learn in this lesson? Climate in human life, global climate models, and how climate models are used to predict future climate scenarios. Climate directly affects all activities of human life. For this reason, the idea of predicting the future climate has existed since ancient times. In line with the desire to cope with the problems that human beings have encountered since ancient times, when the scientific method was not yet defined, to understand the universe and to master nature, and to live more comfortably and safely. He felt the need to conduct experiments either on the system itself or on an abstract, concrete model. For this reason, the concept of modelling has developed over time. Modelling is making lifelike images. Models help us test the hypotheses we have constructed. Therefore, the use of models in the field of science is inevitable. On the other hand, a model is an idealized version of reality. It is often a simplification of the complex. Models are dynamic structures that can change with new information. With the developments in the field of computer technology in the 20th century, the concept of modelling began to be used for climate. Global climate models. Despite all its complexity and difficulties in implementation, the most important tool in predicting the future climate is climate modelling. In this way, the general framework of the climatic conditions after a certain period of time is tried to be drawn by taking into account the current situations and making various calculations. Regional climate models, RCMs, are numerical tools used to simulate the climate of specific geographic regions, ranging from a few thousand square kilometers to entire continents. They typically include atmospheric and land surface components, and some also incorporate ocean, sea ice, and aerosol models. RCMs simulate regional climates based on global climate conditions at their boundaries. All climate models are basically. They are designed to take into account the energy coming from the sun through shortwave radiation and the energy going from the Earth through longwave radiation. Any change in this balance leads to changes in temperatures. The Global Climate Model, or General Circulation Model, is a climate model in which fluid movement and energy transfer are integrated over time. Unlike simple models, in these models the atmosphere and ocean are divided into horizontal and vertical calculation units, called grids. How climate models are used to predict future climate scenarios. Once a climate model can perform well in hindcasting tests, its results for simulating future climate are also assumed to be valid. To project climate into the future, the climate forcing is set to change according to a possible future scenario. Scenarios are possible stories about how quickly human population will grow, how land will be used, how economies will evolve, and the atmospheric conditions, and therefore climate forcing, that would result for each storyline. Around the world, different teams of scientists have built and run models to project future climate conditions under various scenarios for the next century. So the groups can make a fair comparison of their results. They run the same experiment. Because each climate model is slightly different, the results show a range of projections. Though yearly values projected for temperature and precipitation differ among the models, the trend and magnitude of change is fairly consistent. Global climate model results from Groups Around the World project that global temperature will continue to increase. They also show that human decisions and behavior we choose today will determine how dramatically climate will change in the future. Let's watch a short video related to our topic.
It's the year 2060. Lars would like to visit his old hometown of Hamburg. But what's this? Where are the ships on the Elbe that he always used to watch? The Elbe has almost dried up due to climate change, bringing the shipping industry to a halt. Could this really happen? The possibility of this and other similar scenarios is being studied in the research project Energy Transfers in Atmosphere and Ocean, a collaboration between several institutions in northern Germany. The project uses computer simulations to predict climate variability in the next few decades. These climate models are based on the laws of physics, which are formulated as mathematical equations. In addition to these laws, the models use a variety of data from experiments and observations. Powerful computers can then calculate a climate forecast for the future. These should not be confused with a weather forecast. With a climate model, considerably greater periods of time are taken into account, and many additional parameters are considered, such as an increase in CO2 emissions to the atmosphere caused by humans. But what does a climate model look like? In the models, the atmosphere and ocean are overlain with a three-dimensional grid. At the grid points, the temperature and strength, as well as the speed of the wind, for example, are calculated in time intervals. The computer can therefore only calculate approximate values. These rough figures become more accurate if the grid is smaller, meaning it has more grid points. However, a computer then needs considerably longer for the calculations. To optimize the use of computing power, the researchers have done the following. They distribute the grid points differently in various regions, depending on what they want to study. For example, more grid points can be placed in coastal regions. Until now, the option to vary the distribution of grid points has rarely been used in climate models. Additionally, important details such as vortices or waves have been left out, and it is not clear what effect these omitted details really have on the climate. The researchers involved with the project are trying to better understand this effect, and in doing so, they are helping to develop more precise climate models. Therefore, the initial scenario may not happen, because the models will be improved and people will prevent climate change. And Lars will still be able to watch the ships on the Elbe in 2060.